Our last section to discuss is exactly how Stope Examine works. I will reiterate before I start here that this is not a tutorial or an example on how to use the software. This is more focusing on the purpose of Stope Examine and the inputs that we require. So let's firstly take a look at required fields. Required files, I should say, step one. We'll need stopes, so these may be in DXF or STL format. It's optional to have development solids, topography, an area of interest, any historical mining, and then you'll also need your rock mass domains and your mining steps. Just if you're unsure on what any of these are, rock mass domains indicates you'll need to separate the different lithologies in the area. You'll also need stope shapes. You can have, but do not need to have, development. And you may also want topography. A topography solid becomes important if you want the elevation to be automatically set forth in situ stresses by Stope Examine. Otherwise, you can simply take a reference elevation, but we'll get to this a little later. The second step of using Stope Examine is for the user to define some settings. This is most easily described by having a look at this screenshot of the Stope Examine software. Firstly, the geometry file format can be in either STL or DXF form. By selecting a folder here, we're pointing Stope Examine to a directory in which might case all our required files that we discussed before. So this might be stope shape DXFs or STL files, development drive solids, topography, DXF or STL, and any rock mass domains. They can all be housed in one folder, and then you simply point Stope Examine towards using that folder to make the whole process quicker and easier for the user. You may want to import a model mesh. This will allow Stope Examine to bring in your old model mesh template, which allows you to not need to use these global octree meshing parameters down here. Simply bring in a template. And then also you can untick or tick the option of do you want to import geometries from a Map3D model. So let's get into these global octree meshing parameters. What exactly does the user need to enter here? Firstly, it's important to note that Stope Examine uses the term zones as opposed to elements. The reason for this is zones is the term used in FLAC3D, and to keep the nomenclature consistent as the two softwares generally are used in conjunction with each other, we've also opted to use the term zones as opposed to element. But those two words are relatively interchangeable, so don't let that confuse you. Firstly, we put a target number of zones in the model, so the maximum number of zones that you're going for. A far field zone size suggests the size of zones towards the outer boundaries of the model. The model boundary offset is the distance from the area of interest to the outer boundaries, and the required zone size is the smallest zone size that you're going for around the area of interest. So if we have a little look at these displays here, we can appreciate what the model boundary offset looks like. So it's really the distance from our area of interest here, being some sort of mining stope setup, the distance to the model boundary. We've also got any sort of exactly how octree meshing works. We get a geometry to be meshed, we do a first overlay second, then things start to get divided selectively. And up here we can understand exactly the importance of far field zone size. So note the far field zone size is much larger than the zones required over the area of interest, in this case a side-on stope. So that's the settings that you really need to set up. Step 3 is model construction. This process is achieved entirely through Stope Examine. So by looking at these screenshots, we can have a little look at, for a given stope, we might upload a DXF file. We have a look at the zone densification distance, which I'll get to exactly what that is in a moment. Relative geometrical accuracy can be set to maximum or minimum, and all that is the bias towards your smaller elements. So if you really want the accuracy in the model to be biased towards the area of interest and you have all your smallest elements at that area of interest, then you should have maximum. Whereas if you want more of an even spread across all the elements, regardless of their size, you can put minimum there. And your smallest zone size is simply the smallest possible zones that you want in your model. So as this is fairly consistent across all types of upload files, so I'm not going to go through all of them here. We will have a little look at this chart though, or this picture, that describes exactly what the densification distance is. Zone densification distance is the distance from the area of interest, in this case the area of interest is a stope, that elements remain the smallest zone size. Zones remain the smallest zone size, I should say. Again, those words are fairly interchangeable. So only, let's say this is 5 meters from a stope, my densification distance, only within 5 meters would zones be of the smallest zone size. Then after that, we see that it tends towards the far field zone size. So that's your model construction. Step 4 in using the Stope Examine software is to set up the rock mass domains. It's mainly important here to appreciate that the Stope Examine software can host 10 domains plus a default host domain. So you've got 10 additional domains to go with plus a default host domain, which will be the default for all zones in the model. You have options for isotropic and anisotropic rock, and you also have down here a little backfill option, which is a very powerful and simple to use tool. If we go through the process of creating the domains, it's fairly simple to add a domain. Just simply click the big blue cross that allows you to create a new domain. You may choose to create an isotropic or an anisotropic domain. You can input any parameters like basic linear elastic parameters, density and Young's modulus, but then you may also go so far as to add any sort of Hooke-Brown parameters such as MI or intact rock strength, which will help the improved unified constitutive model down the track. That's really your rock mass domains. Step 5 of using the Stope Examine software is to consider in situ stresses. I mentioned earlier when we spoke about topography, ground surface elevation. This ground surface elevation will not be an option to input if you have input a topography file, because the topography elevation will be taken as the ground surface elevation for all points of that topography file. Whereas if you say don't have a topography input file, you can just choose an average elevation here and it will take any stresses starting at that point. Stresses are then input in megapascals per meter. Plunge and trend are fairly interchangeable with dip and dip direction if you're more familiar with that. And it simply indicates which orientation these stresses are acting in. So we have respectively here maximum, intermediate and minimum principal stresses. The minimum often is referring to the smallest principal stress in a mining scenario will be the vertical stress. So here I've indicated that this minimum stress has a magnitude of 0.028 megapascals per each meter of depth. It has a plunge of 90, indicating that it's completely vertical, and its trend is 360 degrees towards north. The locked-in stress in this case is the stress at the ground surface elevation. So if for some reason I wanted at a surface elevation of 0, i.e. the free surface, I wanted a 5 megapascal stress, and then we increase from there, so the starting at surface stress is 5 megapascals, I would put the number 5 here. But in most cases, the free surface stress is going to be 0. That's how we handle in situ stresses in Stope Examine. Our final step, step 6, that we're going to look at here in the Stope Examine software is solving parameters. So that is to say, how do I want this model to be solved exactly? Now we've had a look at mining steps before. It was in our required files for input. A mining step in this case is exactly how the geometry is extracted. So it's not necessarily one stope shape, although it could be, but your mining step 1 might be several stopes on multiple levels of your mine. It's just chronologically how are these stope shapes taken out of your mine. So in this instance, I've put that there are 10 mining steps. Then I can say the first mining step to solve. I've said number 1, but let's say I've already run a model and I've done the first 4 mining steps earlier, or they're historical mining, so let's say. Well then, I might choose to start my model at step 5, and then the number of mining steps to solve. So I've said there are 10 mining steps. We're going to start at number 1, and now I'm going to solve all 10. But if I didn't want to solve all 10, I could put the number 6 in there, let's say, if I only wanted to solve 6 steps. Your FLAC 3D solving cycles are how many times you want to cycle FLAC 3D through this. The model runtime will increase with an increase of this number. That's the end for our solving parameters and the end for how it works.